because a few years ago I was hacking in 2019 and 2020. Now we're back here sponsoring, so we're really excited. So we're going to show you today a preview of AR glasses that we've been working on. These are glasses for all day wear. They're super hackable, they're super open. These are the glasses that we wanted to have ourselves. I've actually been wearing Google Glass before this company for nearly 12 years, and I think Google actually got really close to having kind of a miniaturized experience, or really great kind of all-day experience in miniaturized glasses. And so we see Ray-Ban glasses very much kind of a spiritual successor to it, but super open and with new input and new features that we think will be really helpful for all-day wear. So I'm excited to get into that. Just quick intro again, I'm Tom. I've been working in AR basically since 2012. Started wearing Google Glass in 2013. My first company was called Teleportal, and we did massively multi-user AR/VR networking. So we had a kind of SDK there as well, and now working on the hardware side. And I'll hand it off to Parth.
Hello everyone, I am Parth, and I'm working on software and human interaction for Ray-Ban. So all the dev SDKs and first-party apps that you'll see. And so any questions you have about dev SDK, I'll be the person. I'm really excited because I've been in the area for like 4 or 5 years, worked primarily with Meta and Magic Leap and other places. And yeah, I'm excited. We met at the same research lab, we have some overlap. And I've been in Reality for this is my 5th time, I think. But I've done hacker, organizer, mentor, judge, and first time sponsor. So I'm really excited.
Cool. Thank you. All right. So we've all seen a lot of AR and VR devices over the years, and I think one of the things that is always tough about this category of device is that we're trying to fit so much compute and so much kind of high fidelity input and software and optics and all this stuff into a very small form factor. And this has been the holy grail of whatever we've been talking about in AR. High field of view, very immersive experiences in something that looks like glasses, or maybe at some point, contact lenses. And one thing that's happened over the past few years is we've seen higher and higher fields of view and bulkier devices, or we've seen kind of microcontroller-based glasses that don't provide a lot of utility, but they are super lightweight. And so there are examples on either side of the spectrum. And so we're not here to say that what we're doing is we're going to have everything high field of view and this inside of a pair of glasses. We're trying to be very pragmatic about what the technology is capable of now and what we can build now, leading up to kind of a spatial computing future. And so our operating system is Linux-based, and it's designed with openness in mind, it's designed with privacy in mind for user data. It is designed with hackability and mutability, and but we're putting this all into a form factor that can actually be done today with current technology. And so the form factor that we have, and this is actually, I'll show you a couple of examples. This is the final form factor here. This is actually Ray-Ban Glass V1. This is what we're going to be shipping in the first half of this year. And it has full color light engine, so it's a 30-degree diagonal FOV, which is great for head-up display uses. It's also great for reference material. It can be kept on for a very long time. We've got eye tracking as the primary input, so it's super easy to use. You'll actually see some of this interaction at our booth and the hardware, but the eye tracking is really a neat way to interact with it. And then there's also hot swappable batteries on the back, so I'll have Parth demonstrate that. But this kind of gets around the all-day battery life issue. So there's actually 3 batteries in this system. There's 2 on the back. We call these, this is Ray-Ban Glass, we call these the Ray-Ban Wings. The Ray-Ban Wings each have some battery in them. They're also hot swappable, so you can actually pull both of them out of the system, and there's a smaller internal battery in the left stem there that will keep the DRAM clocked, so you don't lose any data as you're doing your swap. But yeah, on the side here, this is actually something new that we're showing at MIT Reality Hack. On the side there, we actually have the speaker. We've got, of course, the battery in the back. We've got the light engine. But that part right there is an entire Linux computer. It is a 64-bit quad-core ARM system running full Linux. We can actually SSH into it. and do whatever you want. And this is that board right here. So we have most of it covered up because our chips chips are under NVDA, but you can kind of see everything that's inside there. So this is a little chunk of the right stem containing the speaker and the logic board. Yeah, so this is while we're here at Reality Hack, we actually have hardware, kind of benchtop development hardware for everyone to hack on. We have been hard at work. We've been pushing the fabs really hard because this logic board is actually a lot smaller than what's in an iPhone. So it's kind of a similar amount of compute, but a fraction of the size of even an iPhone 17 logic board. And as a result, this is really hard to manufacture. And we've been kind of pushing our manufacturers to take this design that we've kind of built in-house and try to apply it to the real world. And so we have it working, but unfortunately we did hit some fab delays, so we don't have final glasses hardware here at MIT, but we do have these development hardware that you can use. And so everything in that box there is miniaturized now into this small board. This is just a quick comparison of the Meta Ray-Ban display, which was launched recently, and then Ray-Ban glass, and you can see kind of the difference. And so we're trying to make it look and feel like normal glasses. So yeah, quick update, or quick overview of the tech specs. As I mentioned, 30-degree, diagonal field of view. We do actually have multiple microphones and speakers around the device. So there's a few microphones around that do beamforming, that do noise cancellation, and acoustic echo reduction and that kind of stuff. Eye tracking, on-device compute, Wi-Fi, Bluetooth. One interesting thing about the Wi-Fi and Bluetooth, as we've seen on many devices, Wi-Fi is very power hungry. So we try to run a pretty decent kind of power management scheme, duty cycling Wi-Fi, and just running Bluetooth whenever possible, and then Wi-Fi if you actually want to hit a cloud or a server in the cloud or something like that. But what's cool is that there's so much compute on here that you can actually run your text-to-speech model, your speech-to-text model, you can run small language models, you can run basically anything on the device, except for, I don't know, super large language models.
3.7.
Yeah, you're not running Llama 3.7 on it yet, but it's just not enough for him. Cool. And then we put up this Medium article recently of design decisions that have been used in the device, and so we spent a lot of time trying to figure out where should the display be, for example, and where how do we want to actually architect the rest of the system. And so all of that, those kind of a little bit more details on those design decisions are available. So this is a real photo. So all these photos we have in the deck here are real. And so this is a photo that I took the other day just with my phone through the waveguide. This is not color calibrated yet. It's just kind of straight out of the waveguide. But you can see these are some of the applications that we have, and I'll let Parth talk about the rest.
Yeah. So we have a bunch of applications. So these are just, you see all this on our booth. So these are just to show the capabilities of the device. So almost any app on your iPhone can run on this. Any app on your laptop can run on this. Like basic apps like camera, news. I should put text on this. But camera, news, some cooking apps, some Shazam. Like Shazam is my favorite app on the glasses that I'm using because just whatever music it comes with the lyrics and all. So a lot of cool apps. The coolest one is Pin2View and ScreenShare. Pin2View is basically you can pin any thing like a YouTube video or an image or an IKEA manual or anything on the display. And you can also AirPlay on this. So so you can basically screen share whatever you want on there and it'll be like reference material. So those are just some of the apps, but very excited to see what you guys are gonna do. And these apps actually kind of reflect a lot of our design decisions. So if you're looking for inspiration or see what we've done, you can check it out. So for this hackathon, as Tom mentioned, we didn't have a final form factor, but we do have these benchtop kits. So you see there's a waveguide over there. So our simulator that I'm going to do live demo of is pretty capable, so you can build most of it on the simulator. And we have like 3 benchtop kits. We were initially planning on loaning them out, but we got so much interest already that we're planning on just having them on our table, and you guys can come and see your apps on the table itself. But the simulator is available to anyone. So this is the benchtop kit, and as Tom mentioned, it has a lot of compute. That's in that computer there. It's living space, and which we have managed to put it all in that one board. Moving through, yeah, some more images. These are all real images, and you can see these prototypes on our table. Okay, now the SDK. So again, it's living space. So anything you can run on your computer, you can in theory run on this. But to make coding as simple as possible, we have a very simple Python-based SDK, which is simple for developers, but it can do a lot on the background. So it's simple Python-based, so literally pip install Raven framework, Python main.py, and that's it. 3 minutes max for that's just installation, given that it's a Python version. It should just work. And I'll show it to you right now. This we will give access to all our sensors. We're not going to gatekeep anything. Cameras, microphones, speakers, eye tracking, IMUs, everything is open access. Of course, once you have an app store, we'll have some entitlement checks, similar to how Apple does it when you're publishing apps. So this comes with a complex UI kit. So like things like buttons or how you scroll. We've done a lot of research on getting these interactions right, because this is an eye tracking based system. This is one of the first primary eyes based input system that we're going to have that doesn't come with like 20 cameras with which you can pinch. So a lot of these, we put a lot of thought into it, and we suggest using the buttons and the containers and other components that come with the kit, because we're going to keep updating those as we go further. And we are, as Tom might have mentioned, we are building the iPod of AR right now, and we're going to get to iPhone very soon when we have spatial OS and everything, and all these components will travel through. So all these buttons and all those tiny little things will go through. So this will be scalable to our spatial OS. And this SDK is built for GenAI. So if you have Cursor, Cloud, any agentic tools that you use, it's from ground up. It's built for these agents to perform. There's literally documentation for agents in there to design UIs, build interactions, and how to use a component. So we literally had a beta hackathon or like an alpha hackathon like this weekend, and like people built like 5 apps in an hour with the agentic tools. They didn't write a single line of code, but those apps are pretty good. So you should definitely try that out. But yeah. And this is the QR code to our starter project, which we forgot to publish and I've published right 5 minutes before. So this is what, if you're going to participate in the hackathon, this is what you'll be using. Can someone give a thumbs up if the link is working? Yeah. Okay, beautiful. So this is our...
Yeah, this is very exciting for us. This is the first public release of our SDK ever. This is actually technically the first release of a Raven product here at MIT. So the next one will of course be Raven Glass, the hardware, in a few months. But yeah, we're excited to hear any feedback. This is like an alpha v0.1. Please give us feedback.
Yeah, and it has linked to the actual SDK. So this is the starter project, and I will run through that after this slide, I believe. Yeah. Okay. So let me run over the framework real quick. So as I mentioned, we have a lot of UI components. So like anything if you've used Swift UI, React, simple things like containers or buttons, and tons we've tried our best to make it as simple as possible. And these are interactions like you dwell on them and click. So you have to just have functions to what to do when the user clicks on it or where to place it, and that's it. And rest all the animations and everything is already programmed in. So you can see for this button, it's literally just button, send text, icon. And you can have a callback here on button click. As simple as that. Let me show you some examples that will make sort of. So this is the starter project. So a simple Hello World app. You just place a container, put a text box in it, add it to the app, and run it. Like literally I think 10 lines of code if you remove the comments, and that's as simple as it gets. We have all struggled through Unity when we were making VR and AR apps. It's taking like 3 hours to do a Hello World. So I think everyone can use it. So we tried our best to make it as simple as possible. And the documentation should have a lot of details, like simple things like timer routines or how you scroll or you exit an app. There are a lot of cards that you can just, which are UI components, so which come off out of the box. This is actually, fun fact, this image is in MIT Media Lab. This is the 4 cyborgs that started wearable computing as an industry. And the one in the center, Thad, this one, he was a research professor. Me and Tom both worked in under Georgia Tech, and he basically pioneered Google Glass. And the guy on the left, to the right, in the blue shirt, in training, he's on our team. He'll be landing very soon, actually, and we'll get to meet him too. But from that, yeah. So let me show you the starter project. And the simulator. So, for example, I just ran Python main.py, and this is our simulator. So you see there are like a lot of dwell animations. So dwell basically means, for those who don't, like if you look at something, so your cursor here is simulating gaze, and that background is transparent. So we are trying, so this exact window will be on the glasses, and the waveguide based displays will kind of do an additive blend, which is it'll take the brightest color and pick that out. So black will never show, and white will be the best color. So you can see a reflection of that, how it will look like on the waveguide. But anyway, that's just one app. Let me show you some more apps. So this is a good app for the example of our interactions. So why is that slow? Oh, now we do. Wonderful. Okay, so for example, the window management on this, I never screen shared it. For some reason, beautiful. Okay, so for example, if I'm looking at this, how do you scroll? This is just one method we're implementing. You look at the sidebar and you just dwell on the page and you want to scroll to. And then you dwell on a button and you open the app. It's things like these, and there are a lot of design decisions around it. Like for example, you see a lot of the displays like offset to the right, like the image. Our entire display is offset to the right, because these are things like, for example, the menu is something you will be actually interacting with. So you should have it in the central, because user will be just using it for a minute. But then an image that they're seeing with their view world, it should be in the periphery, because that's something they'll want to have inside and focus on the real world. And the buttons, like the home button now, and very tough to reach positions like the top right corner, which is very hard to look at, because you don't want to click them accidentally. And then the scroll, instead of like slide scroll, like a lot of people say, why don't you have like a sliding scroll? It's because you're looking the same place where you're interacting. So like if you're sliding, you notice you're looking at the content further and your hands are just doing it. Here you're looking as well as. But these are all very initial levels and all are subject to a lot of testing. But this is just one example.
Yeah, and one of the questions that we get pretty often is, how do you click? Because if it's all eyes, so the primary input method is eyes on Raven Glass. The secondary is voice. So we use voice for things like text entry, but we find that voice is actually not a great interface when you're out and about or when you're trying to keep your interactions with the device private. So most of us, when we use our phone, we're not. We may dictate into the phone, or we may ask it, for a quick query, through Siri or Google Assistant or whatever. But when you're doing, you're actually interacting with the phone, it's all touch. And so with eye tracking, it's actually really difficult to determine, is it click, is it not? We've explored a lot of different methods. So there's kind of two main methods here. One of them is dwell, which is what you're seeing here. So if you Parth just keeps his cursor and doesn't touch it, it's going to simulate kind of just keeping your eye steady there. So that's one way. And then the other way is if you click on your trackpad or on your mouse, it's actually going to simulate a double blink. So that's another selection method. And we have some more that we're coming to, but those are the two that are definitely in Raven OS.
Yeah, and feel free to implement anything. So, because this is an open, it's Linux, so you can create any HID, any mouse, any ring, any EG, EMG, bands, anything works with it. You just connect it as the Bluetooth connection. Like, we literally, the benchtop setup we have, we just have a regular Bluetooth mouse plugged into it. And you can put whatever input you want. So all that works. And because these use native clicks that any HID input would recognize, so any mouse or any Apple Watch, even Apple Watch has some third-party apps with which you can click. So all that works.
And another interesting thing is, because it's Linux and because it's ARM64, if there are libraries or other libraries or other pieces of software that you want to integrate into your applications, in addition to using the Raven framework, it will work seamlessly.
I just wanted to show how do you actually get started, because I just went over what the this was basically all the capabilities. Do you want to just get started? All you have to do is clone the repo, pip install, and that's it. We still haven't published it on pip, so you have to clone the repo. So just clone the repo, pip install, and just run that. And then you can just start coding. And as I said, there's enough documentation for even agents here to understand and build apps, so feel free to use any of that. Yeah, and it comes off and a lot of people are asking about AI and other things. It comes with a lot of things. I'm going to show you out of the box AI helpers. So for example, we have a wrapper for OpenAI helpers. So literally the image format that we'll get in, we'll convert it and run a multimodal query. So let me show you simple AI. So this is a very simple AI app in which you just ask me anything you're looking at, and once they click the button, start recording. See it. And it'll just, so we have a Celadon agent to transcribe audio, camera capture the image, get text response, and all these are inbuilt functions that come in. So just some capabilities of the SDK, and feel free to come by our desk and to know more. Anything else you want to cover, please?
Cool. Another thing we want to announce, we mentioned this before, if you're in our Discord, you may have seen this, but alongside the Raven last launch of actual devices being out in the wild, this year we're going to be launching a developer lounge. So we have a lab space in San Francisco. That's where we build all the software and hardware, we do firmware, electronics, optics, everything in-house. We also work with some great partners in the Bay Area and beyond, but all of the kind of system integration and design and engineering happens in our lab. And so we have a kind of an extension to our lab space, which is going to allow you to try out the classes, and then also to have direct access to our team. So if you happen to be in the Bay Area, either live there or just stopping by in the Bay Area or in San Francisco, we would love to have you by when this launches, and it should be at some point in the first half of this year. But we'll keep everyone updated on our Discord with that. And this is kind of, you know, as we've mentioned, you know, there's been a lot of AR, VR devices over the years. I think inherently in the AR, VR, kind of looking at any of these devices, it's I think we're all wise to be quite skeptical of, you know, marketing claims and all of this. And so what we've tried to do is just build, again, the device that we wanted to see others build for a long time. And not say, and I won't promise we're going to do this large field of view thing or whatever, but just build, you know, kind of that iPod that Parth was mentioning. Like build the iPod of AR. What is the thing that's going to do a few things really, really well? And, you know, I guess more open and hackable than the iPod was, but still kind of that ethos around use cases. And then that kind of allows us all to move up to this, you know, iPhone of AR, this fully spatial, you know, device. And so we're kind of right now, you know, we're really in like 2004, 2005 timeline right now. You know, 2007 when the iPhone launched is coming, But it's important to keep in mind that what we do right now, as you know, an AR/VR community, both building applications and building hardware, is all moving into that direction, and we can lay the right foundation right now. So yeah, that's it. Thank you for coming, and we're happy to stick around for any questions.
Can it run Doom?
The first question is the guy Raimi. That was the first question he also asked.
The answer is theoretically yes. We haven't tried.
If you can run it on Linux, you can run it here.
Yes, we would love to see someone run Doom on it. It should be pretty straightforward.
For the,
Yes.
really quick, so there was an interaction screen and then the right screen was a sim screen, right?
Yes.
That was not stereoscopic. Is the device stereoscopic? Is the user interface volumetric? Like what?
So the device is monocular. It's a monocular 30-degree, it's like an LCOS panel with a waveguide. And we've opted for monocular for a lot of reasons. We actually think about the design decisions. If you look at the design decisions document, we actually talk in depth about why we went with monocular over binocular. And so it is, we will do binocular once we do a fully spatial device. It's kind of in a future generation. And as Parth mentioned, all the UI elements and everything that's built on the SDK now is actually with that in mind, so it will seamlessly transition. And actually a lot of the underlying operating system architecture is with spatial in mind. But for right now, yes, it is monocular.
So the device has cameras. Does it support any SDK capturing data from those cameras? And also, can you use that data for hand tracking?
Yes.
Yeah.
We have tried running MediaPipe on it. So you can run MediaPipe or any hand tracking algorithms. OpenCV runs. So the answer is yes. We have seen some MediaPipe functions that require complex models, take a lot of RAM, that don't run best. But you can run hand tracking if you wanted. Though the camera's field of view is limited, so I would keep that in mind because people have to move their hands up. And we've seen in design decisions that like a lot of interfaces that make people move their hands and do a lot of things.
Yeah.
So,
But it is possible.
yes.
Yeah,
What's
to get
the-
full access to the camera feed.
What's the field of view on the camera?
Subject to change, but it's about 90 degrees.
Hmm.
And so it's kind of a pretty typical, smart glass camera.
Is there any reason that blink detection is something you guys don't have implemented in the project? Just pointing the vehicle and looking through it right now.
Yeah, so blink detection is handled on the device, like on the hardware side, or on the firmware, but it's just simulated with a click right now.
So a click on the simulator will translate to a double blink.
Yeah.
Okay.
If you're talking about kind of understanding a blink without a click, we could also explore that kind of just like, I guess, separate of actual UI elements being there, right? Like a blink recognizer. That's something we could certainly implement.
Because the eye tracking peripheral right now only gives gaze coordinates. It doesn't give eye openness. So, any other questions?
Have you guys looked into the thermals of the device?
Oh, extensively, yes.
That's the biggest problem.
Yeah, so yeah, all of these are, you have the thermals, you have the optics, you have the weight, you have, all these are trade-offs. Pretty much, I mean, like, in a CPU, of course, it's basically a, almost perfectly efficient space heater. You get most of the electricity that goes in becomes heat on the way out, and so, if you pump 3 watts through a really tiny chip, well, first of all, that's going to drain the battery a lot, but it's also going to meat sink, we call it, into your skin. And so we're very cognizant of that. The chip that we have is pretty efficient for a lot of things. It has hardware acceleration for DSP and GPU and some neural processing as well. So it is more efficient. We also do have co-processors that are outside of the main SoC. There are separate chips that handle certain things, like eye tracking, for example, is not directly on the SoC. So we can be a little bit more efficient. Materials also make a big difference. So there's on kind of the internal side here, it's actually titanium. And so we have different kind of thermal properties with this, being able to heat sink across the surface. Not saying titanium is the best material for that part, for the thermals, but there are kind of mechanical engineering choices that allow us to kind of whip the heat away as well. But yeah, thermals are a really fun challenge. Absolutely. Cool. Well, yeah, so we will be here the entire hackathon. There's 4 of us here. As Parth mentioned, Raimi is flying in right now. And then, it'll be us, Colin at our booth, and Raimi. So we're all around to help with your projects. We should have pretty much 24-hour coverage on the SDK almost. So, feel free to ping us anytime in the Discord.
We are also trying to do another workshop. It's not confirmed yet. During the hackathon, potentially tomorrow. It will be like a longer 2-hour-long workshop where you can just come and build an entire app. Because as I said, in our beta after hackathon, people build 5 apps in 1 hour with their agents. So you can just come and build apps, and I think we can give prizes to top 3 teams.
Once it's confirmed.
Once it's confirmed by the organizers, by the hackathon, we can give some prizes, top 3 people, individuals who build an app, something like AirPods or something, subject to confirmation. We'll confirm it by opening ceremony. But do keep an eye out for that as well. And this is our Discord.
Yeah, so feel free to join the Discord. We'd love to see you in there. We'd love to keep you all updated whether or not you use Raven in your hack here, because there's going to be a lot of really cool stuff happening over the next few months.
And we really want to know what you guys want, because as we are hackers, we are developers, and we really want to build in public and build with the community. So if there's any requests, any wild thing you want to do, for example, if you want to know the blinking detection or tiny little things, please tell us, switch it out in the Discord. We really want to build what our developers and hackers want.
Yeah, please be very direct. We're very direct with each other on the team, so it's okay to be blunt. Just tell us exactly what you think. Our feelings will not be hurt. We really want to hear your feedback. So.
Any other questions last minute, or we'll stick around here for a bit.